All right, hi guys. This is for 7-1 notes. So we are going to turn to, I think, page 13. We're going to talk about pages 13 and 14. There's not a lot of things to write, but rather just things to explain. I just wanna, sorry. Okay, just make sure that it's working. Let me also adjust a little bit. Okay, so let's talk about this lesson. So we are still talking about ratios or rates, but now we are going to be looking at ratios and rates in tables and or graphs. So let's go ahead and start. On page 13, we have an exercise here, finding ratios from tables. It says students in Mr. Webster's science classes are doing an experiment that requires 250 milliliters of distilled water for every 5 milliliters of ammonia. And if you take a look right here, I have ammonia on top and distilled water on the bottom. And here's that information that was written right here. Okay. 250 milliliters of distilled water, 5 milliliter of ammonia. The table shows the amount of distilled water needed for various amounts of ammonia. Okay, so A, it says use the number line in the first column of table to write a ratio of distilled water to ammonia. So first, I'm actually going to complete the table, okay? And this is the way I'm going to do. So the first thing I want to do is I actually want to simplify. So if you take a look, this one and this one are the two ratios that are completely given. So I'm going to simplify it to the lowest term so that it's going to make my multiplication easier. And the only reason I'm doing that is because when I look at these numbers and then what they want us to do, it's not that easy. Okay, this one's easy. 100 times 2 is 200. So if I simply do 2 times 2, that would give me 4. Okay, however, if you look at the other two, it's not as straightforward. I mean, yes, you could multiply by 1.5 here, but let's say you didn't know that. Okay, so what I'm going to do is I'm going to simplify this by 2. So divide by 2, kind of like dividing your fraction by 2. So then 2 divided by 2 is 1. 50 divided by 2 is, 100 divided by 2 is 50. And I'm actually going to work with that one. And you'll notice that that makes it actually a lot easier. For example, 1 times 3 is 3. So 50 times 3 is 150. Now, let's do one more, the last one. 1 times 3.5 is 3.5. So then if you do 50 times 3.5, it is 175. So 50 times 3 and 5 tenths, 175. Now by doing so, I just made 1, 2, 3, 4, 5 equivalent ratios to this original one, okay? So use the number line in the first column of the table to write a ratio of distilled water to ammonia. Now, order is important. It's not ammonia to distilled water, it's distilled water to ammonia. So this number needs to be first, okay? So it says use the number in the first column. Where is the first column? The first column is this one right here. First column, second column, third column, so on and so forth. So then distilled water is 100 and ammonia is 2. So my ratio of distilled water to ammonia on the first column is 100 to 2. I wrote it here because of these lines. Okay. B, how much distilled water is used for 1 milliliter of ammonia? Well, fortunately, I actually found it right here already. For 1 milliliter of ammonia, 50 milliliter of distilled water. So the answer is 50 milliliter. Now, if you didn't have that information, then all you need to do is find the equivalent ratio. 100 to 2. And then what is it for 1 milliliter? You need to divide by 2. Divide by 2. And that would give me 50. All right? Use your answer to write another ratio of distilled water to ammonia. So since I already found this other ratio, I'm going to go ahead and write that 50 to 1. That's my other ratio. Let me box those answers. The ratios in A, which is 102, 100 to 2, and B, which is 50 to 1, are equivalent. They are equivalent ratios. All of these are equivalent ratios. Okay, so that's how to work with ratios and rates with in a table. Now we're gonna talk about using that same information, to answer the following questions on graphs. Okay, so I wonder if I can show the entire page. Not quite. Okay, I'll work however much I can. All right, so let's take a look at B. So now we are going to talk about use the same table above to answer the following. Okay, in a graph. So we're gonna work with graphs using the same information here. Write the information in the table as ordered pairs. Ordered pairs are order pairs look like this with a comma in between, and the first number represents the x coordinate and the second number represents the y coordinate. In a graph, the ones that go horizontally represents the x coordinates, and then the ones that go vertically top to bottom represent the y coordinates. Okay, so when it says write the information in the table as ordered pairs, use the amounts of ammonia as the x-coordinate. See, ammonia, x-coordinate, which is a first number this time. And the amounts of distilled water as y-coordinate, which is going to be now the second number. Okay, so on the top, they wanted the ratio of distilled water to ammonia. Here, they want x to be ammonia, y to be the distilled water. Okay, so let's go ahead and fill in the blanks right here. 2, comma. So we're going to use the table, not the graph. So 2, comma 100. 3, comma 150. 3 and 5/10, comma 175. Blank, comma 200. 4, comma 200. And then over here, 5, comma 250. So we just did B. Graph those ordered pairs. Because fractions and decimals can represent amount of chemicals, we're going to connect the points. So once we graph them, rather than leaving them as separate dots, we're going to connect them, okay? So the first number represents the x-axis, okay, or x-coordinate. The second number represents the y-coordinate. So the way you're going to graph is like this. First, you're going to go to 2. So to the right, 2, and then you're going to go up to 100, plot a point right there. Now, you're going to go to 3. So to the right, 3, and then top up 150. Now, this one is a little bit hard to graph. So here's 3.5. So here's 3, and here's 4. So 3 and 5/10 is right in between, and then go all the way up to 175. So right about there. Okay, 150 and 200, so 175 is in between. 4, 200, 5 to 50 is already there. And then what you're going to do is you're going to connect them as a straight line. Let me just try to do my very best. Okay. All right. Describe your graph. What does your graph look like? Well, you can see that it's a straight line. So that's what I'm going to write. A straight line. If you correctly write equivalent ratios and you correctly graph, equivalent ratios will always give you a straight line. If you get a point that's outside of that straight line, that means you did something wrong. Okay? All right, C, for each order pair that you graphed, write the ratio of x coordinate to, y coordinate to x coordinate. Y is the distilled water, x is the ammonia. So just like the ones that we did above, they want the y first, x second as a ratio. So let's look at this one, this point. Y is 100, x is 2. So 100 to 2. The next one is y is 150, x is 3. So 150 to 3. The next one, remember it was 175 and 3 and 5/10. So 175 to 3.5. The last one, okay, is 200 to 4. Well, actually, let's do one more, which is 250 to 5. So I just did ratio of x coordinate to y coordinate. Let's answer. Let's box all of these answers nicely. Okay, finally D. The ratio of distilled water to ammonia is blank to 1. So if you look at where ammonia is 1, distilled water is 50, you can also kind of check it right here. If you go to 1, it's 50. So 50 to 1. How are the ratios in C related to this ratio? All of those ratios are equivalent. So I'm going to write that. They are all equivalent ratios. And that's the first page. Now, let's go to the second page. Okay, so the second page is going to be similar information, not much to really write, but I'm just going to be talking a lot about the information from the first page here. Representing rates with tables and graphs. So the first page was ratios. You can do the same thing with rates, but it's the way you look at the information is nothing different. It's the same thing. You can use tables and graphs to represent real-world problems involving equivalent rates, just like how you can represent equivalent ratios. Okay, so it says, an express train travels from Webster to Washington, D.C. at a constant speed and makes the trip in 2 hours. Okay, so if you take a look at the picture, it says 2 hours from Webster to Washington, D.C. And you can see it's 120 miles. In 2 hours, you can get that information here. So for me, I'm going to write that as a rate, just so that I remember 120 miles in 2 hours. Remember, miles on top, hours on the bottom. A, make a table to show the distance the train travels in various amounts of time. Step 1, write a ratio of distance to time. Okay, distance on top, time on the bottom, which is 120 miles in 2 hours. And then it looks like what the textbook did was found the unit rate by dividing by 2. So then that makes it 60 miles in 1 hour. Therefore, 60 miles per hour. Then it says use the unit rate to make a table, and it actually already made the table for you. The first number is time, the second distance. So 1 hour, 60 miles. 2 hours, 120 miles. Okay, then multiplying by 3 hours, multiply by 3, 60 times 3 is 180 miles. And then obviously multiplying by 4, 60 times 4, 4 hours, 240 miles. And then finally, 1 times 5, 5 hours, 60 times 5, 300 miles in 5 hours. Okay, then it says graph the information from a table. Remember, when you're graphing the information, you need to know which one is your x-axis, which it obviously shows as the time. Time is your x-axis, and then your distance is the y-axis. So this is the x, this is the y. So then first writing those order pairs, 1, 60, that's right here, 2, 120, 3, 180, 4, 240, and 5, 300. And then they graph them. Look, 1, 60, 2, 120, 3, 180, 4, 240, and 5, 300. And then connect those lines. Okay. Use the graph to find how long the train takes to travel 90 miles. Okay, so this is important. 90 miles, how long, how many hours will it take? So take a look at this graph. Let's find out where 90 miles is. 90 miles is right in between 60 and 120 miles. So this is 90 miles. So what I'm going to do is I'm just going to go straight right here and make a dot where the line is. Okay, so right there. And I'm going to see how many hours that is. You see that's right here. It's right in between 1 and 2 hours, which is 1.5 hours, 1 and 5/10 hours. Okay, so going back, it says the point, this point is 1.5, 90. This represents hours. This represents 90 miles. So the point 1 and 5/10, 90 is on the graph. So the train takes 1 and 5/10 hours. So the answer to this question problem was 1.5 hours. And you can find that looking at the graph. Now, you can also 60 miles per hour. Set equivalent rate, 90 miles, how many hours? And then solve for the blank. Let me show you. 60 times, if you use your calculator, times 1.5 is 90. So then if you do 1 times 1.5, that gives you 1 and 5/10 hours. Okay, we're almost done. Just the very last part here. A shower uses 12 gallons of water in 3 minutes. Okay, 12 gallons of water in 3 minutes. Okay, complete the table and graph. Suppose the shower used 32 gallons of water. How long did it take? So it actually has 3 things that it wants you to do. These are the 3 things. Number 1, complete the table. Number 2, complete the graph. Number 3, answer this question. Suppose the shower used 32 gallons of water. How long did it take? Now, First thing I'm gonna do is use the information I know. 12 gallons of water in 3 minutes. Minutes, gallons. 3 minutes, 12 gallons. From there, I can answer a few questions such as 3 times 2 is 6, so 12 times 2 would be 24. Okay, but if you take a look, the rest are a little difficult to figure out. So what I'm actually going to do is first I'm gonna simplify this ratio by 3. So I get 1 to 4. Then notice how it's gonna now be much easier. 1 times 2 is 2, so 4 times 2, 8. 1 times 3 is 3, 4 times 3 is 12. 1 times 4 is 4, so 4 times 4 is 16. 4 times 5 is 20, so 1 times 5 is 5. So I did the first one, completing the table. Now I'm going to do the second one, so I'm going to graph it. I know that the time is my x coordinates, and water used is my y coordinate. So then my order pairs are going to look like this. 2, 8, 3, 12, 4, 16, 5, 20, and 6, 24. I'm gonna graph those points. 2, 8, 3, 12, 4, 16, 5, 20, and 6, 24. Okay, and straight line, so I know that I'm doing it correctly. Now I'm going to answer the last question, and that's the lesson. Suppose the shower used 32 gallons of water. How long did it take? I'm going to solve it using 2 different strategies, one looking at the table, the other one looking at the graph. So 32 gallons. So I'm going to try to put 32 here and find out what this is. So take a look here. 4 times 8 is 32. So then 1 times 8 is 8. So the answer is 8 minutes for 32 gallons of water. Okay, another way you can find that same answer is by looking at the graph. But looking at the graph is sometimes a little bit more challenging. So it's not something I would recommend if there's a different way. What you do is you go to 32 gallons, which is right here. And then you go find the graph. Here's a point. And then you go down 8 minutes. Okay? But then if you can take a look here, because I didn't do a perfect job at drawing a very straight line, honestly speaking, if you go to 32, the line is actually not exactly at 8 minutes. And that's what I mean by sometimes using the graph to find the answer is not as easy. Because if the person didn't draw a very perfect graph, then you may not be getting the correct answer. All right? My preferred method is to use a proportion, such as, you know, I don't know, so like 4 gallons for 1 minute, set it equal to 32 gallons for how many minutes? Then since 4 times 8 is 32, 1 times 8 would give you 8, like that. That's my preferred method. Okay, that's it. Thank you.